with the time we have. About 45 minutes. All right. I'm not going to do roll. We don't got time for that. All right. Number one's a bad question, the best I can tell. I think it's the only mistake on the exam that I found. It's the only mistake I ever made. Here it is. Boom. No, sorry. I apologize. One's a bad question. B and D both seem right, and I think the answer said E or something, didn't it? Yeah, I just messed it up somehow. Right? It should be B or D. B or D look right. Let me help. So it basically, first off, is it an odd power? Remember, the odd powers all look like x cubed, don't they? Right? All the odd powers look like x cubed, and all the even powers look like x squared. You know, like x squared, x to the fourth. All, you know, and this is x cubed or x to the fifth. So first off, it's an odd power. So first off, it's not A, because that's an even power, fourth power. It's not C, that's an even power, fourth power. So it's B or D, first off. We good to there? And it looks like the middle has been moved back 5, up 4, doesn't it? About? So that means an x value plus 5, because x is always the opposite. This has x plus 5. And then the 4 is, you know, added 4. Well, this has 4 added. And so, I mean, B or D are the same. And they both look right to me. So I messed up the question. Looks like B or D are right.
So
shouldn't be E.
Point on our actual test?
On the practice exam. No. 100 extra points on the practice exam. All right. So we good? So sorry, bad question. Let's move on from number 1. Fast. It'll be on YouTube later. Number 2. Okay, what's the graph? So basically that's the graph of 1 over x. Remember 1 over x has vertical and horizontal asymptotes, like a vertical and a horizontal, right? I call it the crosshairs, and there's a, unless there's been flipping and stuff, there's a branch here and there's a branch there. Remember that? That's the normal 1 over x graph, right? Okay. Well, what's been done on this one? Well, first off, there's the vertical dotted line. Does he have a horizontal asymptote? They're not showing it, but yes, he has to. How do I know? Well, why else is this branch coming down for a landing? And why else is this branch flattening out? There must be a horizontal right here. They're just not showing it. Remember, they don't have to show you the asymptotes on a graph. Those are dotted, meaning they're not really part of the graph. When you graph them on your calculator, you don't see the dotted lines, right? It just is lines of approach, guidelines, that the graph gets closer to forever. But they don't have to show them. You're going to need to know to identify them. Wherever you see the graph approaching, flattening out or lining out, you know, then you know there indeed is an asymptote there. So this one does have the vertical and horizontal asymptotes. And it looks like the vertical has been moved right 1, hasn't it? So that means there's going to be an x minus 1, you know, because x is opposite in the equation. So far, so good. It's got to be something like that. Okay, and then not only that, it looks like it's been flipped vertically, hasn't it? How do I know? Because if you take this graph and you jump him up to there and him down to there, this branch will be up here and this branch will be down there, which is what we're looking at, huh? A branch up here and a branch down there. It's been vertically flipped, hasn't it? See that? Vertical flip, Y, vertical flip. We good with that? So they took the original graph, you know, because normally the normal graph without any flips is up to the right, down to the left. That's what pretty much all of our graphs do, don't they? Up to the right, huh? Unless they're flipped or something. And so this one's been flipped. Somebody grabbed this axis right. Oops, didn't mean to erase it. Grabbed this axis right here like a rotisserie, and they turned it, and this part flipped up to here, and this part flipped down to there. It's a vertical flip, right? This one up here, and this one down here. So it's a Y flip. Now, what makes a Y flip? Well, a negative in the front, huh? Not on the a negative on the X would make a sideways flip. This is a vertical flip. It's a negative right there in the front. Well, how? And not only that, well, and then what's in the back right here? 0, nothing, because it hasn't been moved up or down at all, hasn't it? So forget that one and forget that one, because they have vertical. This one is trying to say down to. It's not been moved down to. This one's trying to say up to. Remember those numbers off to the right, added or subtracted, are vertical movements. This graph has not been moved. The dotted line is right on the 0. It's been moved up 0 or down 0. It hasn't been moved up or down at all. It's been moved right 1, but not up or down at all. You with me on that? Cyrus, I think yours is up here. So anybody, feel free to run up here and grab, if you need a blank test or if you're Scantron, Want to come up and grab it, feel free. They're up here. Anyway, keep moving. So it's not A or D. It's either B or C or maybe none of the above. Now, it's not C because there's no flips on C. You with me? Because that's just a positive 2 up there. There's no negative. There's no flips anywhere. Erica?
What happens if the graph is negative on the x?
Yeah, and we'll see one of those in a minute. It flips it sideways.
Oh, okay.
Negative, which actually would do the same thing. This graph, flipping vertical or sideways, he'll look the same in the end. This one actually could go either way. Right? See, if I grab the original, I flip it sideways, it'll do the same thing. He's one of the rare graphs that'll do the same if you flip it either way. I don't know if you noticed, but anyway, we'll get one sideways in a minute. So everybody see it's not C? Is that okay? It's not C because there's no flip here. So it is B because the negative 2 is a flip. That's a vertical flip. That negative 2, it's being on the top is the same as being in the front. You good with that? It's the same as that, isn't it? Why? Because if you had negative 2 multiplying the front of a fraction, that's negative 2 over 1, top, bottom, it'd go back to negative 2 over x minus 1, wouldn't it? See how it's the same? You guys know that? You want to know that deep within. That, I mean, it sounds so dramatic, but I mean, you want to just know it cold. That a number on the top of a fraction is the same as a number in the front of a fraction. That's the same thing. To be in the top is to be in the front. So what? Well, that means that top thing is like a front multiplier, which is exactly what we're looking for, because we're looking for a negative multiplier, which has a what? Vertical flip, which is exactly what we're looking for. So the answer is B, yeah.
What does the negative 2 represent?
It's negative 2 times, which, well, the negative part of the 2 is the vertical flip, and the 2 is a vertical stretch. It just makes it go up a little faster than it normally would and down a little faster. You can't really see much of that. It just means it just goes up faster and down faster. Vertical stretch, yeah. You can't see the 2 part of it much, but the negative part is very obvious, a vertical flip. Is that good on that? We good there? Okay. Okay, so you just look at the equations. We're talking about exponential. There'll be one exponential, one log graph on the test. So you want to have a bunch of recipes on your 3x5 card, right? Which means steps to make the meal, steps to do the problem. So when you see exponential, you want to have this recipe, that formula. You want to look at that and go, okay, this is always the horizontal. That's the general look of an exponential. That's always the horizontal asymptote, whatever's added or subtracted off to the right. The A is the jump amount from the horizontal to the center point. All right, and the general look of a exponential. An exponential means x in power. We've talked a lot about that. I told you stories of Stalin and Hitler and all that. Try to put in your mind x climbing into power is the big deal we're talking about. And there's special things we need to do in those cases, right? So x in power, that's the unique mark. This is exponential. Horizontal asymptotes at C. And the jump, this is up A. And the normal one, unless it's been flipped or something, goes up to the right. And then, eventually, I'm not drawing this very well, but it comes down for a landing. Oops, what am I doing? There we go. Like that. Good. That's the normal one. So again, all of our graphs, unless they're flipped, the normal original case goes up to the right, doesn't it? Okay. So that's the normal one. So you want to have that on your 3x5 card. So what's the one we have? What's been done? That one's not going up to the right. Ours is going down, flattening out to the right. Can you tell what is horizontal? They're not showing the horizontal, but again, they don't have to. You can tell where it flattens out. It's at 2. It's clearly right there at 2. So that means we have a times b to the x plus 2. Good so far. We've got to have a plus 2 out there because of that horizontal at 2. So forget about a and forget about b. It's not plus 3. It's plus 2. They're testing if you get confused by that 3 there. Right? You're okay, right? It's the horizontal. It's not where it hits. The horizontal is 2. Okay? Now, it's been flipped, hasn't it? What kind of a flip has been done to it? What do you got to do to this original one here to make it look like this one? It's a sideways flip. So here it is, Erica, like you're asking. It's a sideways flip, not a vertical. It's going to go this way. That's what we're looking at, huh? Right? See how that's been flipped sideways? It's like somebody grabbed this and turned it sideways. right? They grabbed this axis and rotated right there. And the right stuff went left and the left stuff went right. It's not a vertical flip. It's not down here. So it's not a vertical up-down flip. It's a sideways flip. So let me just write that. So it's a sideways horizontal X flip. So that means negative on the X, doesn't it? Instead of negative in the front. Negative on the A in the front would mean a vertical flip. But negative on the X is a sideways flip. So we're looking for something with a negative X and a plus 2. So that's C, isn't it? A negative X and a plus 2. Good on that? Questions? All right. Yeah, sorry.
If it did vertically flip, where would we put the minus?
Yeah, it'd be like right here, like might be a -1 or minus something, right there,
Okay.
right in the front. Yeah, because anything in the front is a vertical effector, a Y effector would make a vertical flip. Yeah, good question. All right, we'll keep moving. Log. So here we're talking log. See all the log equations down there. So you want to have in your 3x5 card the general shape of a log graph. So log base b, and the way I wrote it before, I'll write it again, x plus c in the parentheses. And what's in there means at negative c, because x is always the opposite, is a vertical asymptote. So that means back here at negative c, that's a c there. At negative c will be a vertical asymptote. There will be a dot, 1 unit to the right, and then it's concave down, but it goes up to the right forever, like that. That's the general, unless there's been flips and stuff, that's the general look of a log graph. So you want to have that in your 3x5 card. Notice a couple of the characteristics that are different there. The asymptote is in the parentheses for log, isn't it? Because it's an X. You move that dotted line, that vertical dotted line, right or left, don't you, on that? Whereas for that, Michael, your test up if you want to grab it. For the exponential, see that C is not in the parentheses because it's a Y thing. You move the dotted line up or down, don't you? Everybody good with that difference? Okay. So what are we looking at? Where can you see the vertical asymptote on this thing? It must be right here. They're not showing it, but it must be because, why? How do I know? Because that's where the log is taking a dive, right? They always flatten out or vertical out, I guess in this case, at an asymptote line, don't they? It's a guideline. So they don't have to show it. It's dotted, which means it's not really there. It's not really part of the graph. Just a guideline. So it's at x equals 0. So that means the c is just 0. So we're talking about log base b of x plus 0. In other words, just x, huh? We don't have anything in the parentheses. It's just x equals 0 for the vertical, isn't it? You can tell that the log graph is flattening at 0. So it's not b and it's not c because they have numbers in the parentheses, don't they? That's not right. Our vertical is at x equals 0. We don't have anything in the parentheses. Good so far. So we're down to A or D, or maybe it's E. So now, what about, you might look at A and go, well, they have a -2, so that's not it. But that -2 is not in the parentheses. That's okay. So everybody clear, that's a big deal, especially as you go into calculus, is whether, that's why I'm always doing the toaster thing. Whether it's plugged into the toaster or it's outside of the toaster, big difference, right? That -2 is not plugged into the log. That's a Y -2. That's a down 2, right? He's not in the log. He's after the log, outside of the log function. So is this one. That's an up 2. That's an up 2. That's a 2 added at the back, really, right? Now, well, how do you know which one of those is right? Because this graph could be moved up or down too. In fact, it looks like it has been moved. Instead of going right through here, it looks like it's been moved down too, like that, hasn't it? In fact, it has. And in case, but there's something you can tell to make you even more sure. What else? So it is B. It is A. A is the answer. What else is clearly wrong with D? There's a negative on the log, which would mean a vertical flip. Right? Because that's the negative in the front, not on the x. That's a y negative, which would make this graph go like this. And that's not what we have. Our graph has not been flipped. It's going up to the right like the normal. It's been moved, but it's not been flipped. It's going up to the right like the normal state does with no flips. So it's not D for two good reasons. It is A. So it is A. That minus 2 just meant it went down 2. Which you can't see much. I mean, but we know that's it because it's not been flipped. That's the only one that's not been flipped and that has nothing in the parentheses with X. Good? Move on like that. So have those basic states on there. All right, let's try that. I've got a couple actually. Yeah, you reminded me. So let's try that one. So what do we got to do when we have that? We got to make the bases the same?
Yes.
No? Feel free to grab Blake one then. I don't know where it is. Were there extra exams or what did I do with those? Oh, no, you guys kept one. Didn't you keep it? No?
Oh, yeah, I did.
Okay, good. And also I've got Michael. Oh, Michael Glustig. Yeah, that's she. And Karen. You guys just pass those straight back, please. Thank you. All right, let's keep moving. Yeah. So you want to have a recipe game plan when you see these kind of base things. So what do? X in power. That's the Stalin, Hitler, blah, blah, blah. So you want to recognize that and go, oh yeah, X is in power. It's not just that it has X's, but X has climbed into the power zone. So what do you do when you see that? Step number 1 is you try to make the bases the same. That's the first thing you try to make the bases the same. And if you cannot, what if you cannot make them? We'll get to one of those in a minute. What if you cannot make the bases the same? What do? You do the ln of both sides. Well, I should say, yeah, let's just say that. Yeah, ln both sides. Ln both sides. Bring power down to the front. Bring power down to the front. Remember that? That's the great. We'll get to that. So, all right. So, let's solve this problem. So as you look at these guys and you think, okay, there's X in power. That's the whole Hitler-Stalin thing. When X is in power, we got to do something special. Here's the game plan. First, try to make the base same. Can I make the 1/3 and the 9 out of the same number? Yeah, 3. Huh? What do you do with the 1/3? 3 to the -1. Yeah, is everybody good with that? Negative powers flip things. They don't put negative in the front, huh? So this is 3 to the -1. Wait, I don't have room there. Bring it down here. I'm sure you know that, and what you're wanting to see is how the rest of it plays out. So let me get right to that. I would suggest you put parentheses, and that you don't have to. All you have to do in the end is know that these do indeed multiply. That's probably what you're wondering. If you're thinking that, you're right. They multiply. So we get -5x minus 6, and the other one we get 2x minus 4. Does everybody see that on that, Cyrus?
Could you also turn 9 into 1/3 to the power of -4?
1/3 to the power of negative. Wouldn't it be 1/3? Yeah, that's true. That's a fancy way to do that, Cyrus. But yeah, -2 would work, and you could do it. All right, good to hear there. Good to there. I mean, good. So those powers, two powers on the same base multiply. We good with that? That's why they multiply. Anyway, now you just cut out the bases, right? And say, okay, powers are equal. -5x minus 6 equals 2x. So once you make the bases the same, you don't need them anymore. Because if 3 to something equals 3 to something, those somethings must be the same. Or 3 to one of them wouldn't equal 3 to the other. Okay, x is both sides. You know it from here. It's easy, right? Just subtract 2x from both sides. What do we get? Minus. This is going to be none of the above, isn't it? It's not there. Add the 6 to both sides. And I'm running out of room here. -7x is 2 divided by -7. There's the answer. -2 sevens is not there, none of the above. Which is a little disturbing. Sorry, I'm not trying to disturb you, but a couple of them are none of the above. Good there? You okay with that? I'll move on. These power ones. 3 of the power solves. So here's another power solve. So 4 to the x minus 1. 32 to 3. So first thing you see, x climbed into power, Hitler-Stalin thing. You think, okay, got to make the bases the same. So I would take my calculator and go 4 times 4 times 4, and then that's too big, huh? 2 of them made 16. Another one goes 64. It skipped right over the 32. So you think, well, how do I do this? I can't, 4 isn't working to make 32. Right, 4 doesn't work to make 32. So then what could we do? Out of 2. Remember, sometimes we did that in the homework. We had to make them both of them out of some other smaller base. So you make them both out of 2. 2 squared, and this one, use your calculator, is 2 to the 5th. Like that. And then you know the deal. Multiply, right? Powers on the same base, multiply. So this would be 2x minus 2, distributes. 15x, we good to there? and then cut out the bases. So 2x minus 2 is 15x. We have x's on opposite sides. You know the drill. Subtract 2x from both of them. Minus 2 is 13x divided by 13. There it is, minus 2 thirteens, B. Good there. So again, we made the bases the same. Now on number 7, we're not going to be able to make the bases the same. No way you can make e and 4, be the same base. So what are we going to do then on number 7? Natural log, huh? So I can squeeze it in up here. So this was number 6. And so then on number 7, e to the x plus 2 is 4. Yeah, because we can't make the bases the same, you just sneak an L in. You put an L in front of each one. Right? Left side of each one. That's what we have. So Ln is that very special quality that dethrones base powers. It takes powers and pulls them down. Really special. That's why I did the whole Stalin Hitler story, so you'd remember, somehow to help you remember, because there's not an Ln there. You just have to remember on your own to put an Ln in. So remember, Ln does the really special characteristic that nothing else in the math curriculum does, of taking things from the power zone down to the base. That's a really special thing that Ln does. Okay, so what do we get then? X plus 2 Ln E equals Ln 4. So it brought that power down. That's the whole deal. We just got to get it out of power, then we can handle it, right? Sars?
Ln and E together, it just gets rid of it?
Just one. Just cancel right off. Just cancels out, so we just have x plus 2 is Ln 4, so then just subtract 2. Boom, so x is Ln 4 minus 2. And you got to keep this minus 2 separate. You can't subtract those guys, right? Because really it's like this. Really that 4 is plugged into the toaster, that 2 is outside the toaster. Separate worlds, they can't subtract. It's just like that.
Once you do the ln on both sides.
Yeah, becomes a fun. Yeah, because that's what I'm doing. I'm really doing the ln of it. I'm really putting them both in an ln machine. You're right. That's really what I'm doing. I'm plugging the left side and the right side into the toasters. Same toaster. Yep, that's really what I'm doing. You're right. So there it is. Good on those two. Questions on those two? Okay, so number 8. Notice the program I used, the test generator from the publisher who wrote the book. They don't put the bases very low. So I don't want you to be, I'm not trying to fool you. I don't want you to be fooled by that. So it's good. That's part of why I show you practice exam as well, so you're not fooled by style in any way. So that means that 6, which isn't very low at all, that is the base. That they don't lower things very much, and they don't raise powers very high, do they? So watch out for that. Anything a little bit down or a little bit up is a power or a base. So that is a base there. Okay, so how do we solve logs? What do we do? Want to have a game plan for log solving. Log solving. Step 1 is actually to get the log alone, which we really don't need to do on number 8. It's already alone. Step 2 is you lose the log. You cross off the log. And when you do, you know the deal, right? Base stays the base. Other to switch. So that's the recipe you want to have on your 3x5 card for solving logs. All right, so get the log alone. See, on number 9, we'll have to get the log alone first. That one's not alone. But on number 8, yeah, logs are. There's not like a 3 out here or anything. Log's already alone. Nothing in front of it. So just boom. I missed it. Boom. Cross out that log. And when you lose the log, what happens? The base stays low down, stays a base. The other two switch. Instead of 6 to all that x stuff, it's 6 to the 1, and all that x stuff goes to the other side. Good so far. We've got rid of the log. We're out of the log world now. Now, though, you can get to here and get stuck if you don't have the recipe for solving x squared. So x squared. How do you solve x squared with equal? A lot of times, students I've worked with, a lot of them do this, and that's not right. We'll do that in a minute, but not yet. What do we have to do first when we see x squared? Get a 0. Good. So make sure you have that, know that for tomorrow. So when you see x squared, get a 0. That's just got to be a knee-jerk reaction. I said a couple times, wakes you up in the middle of the night, x squared, you got to say get a 0. Get a 0. First step, and then you do the factor, and I think you'll be fine from there if you just remember to get a 0. So just jump that 6 over here, getting a 0, That'll be a minus 6, right? And then factor, I think it'll all come to you if you just remember the 0 part. What multiplies to be 6 and adds to be minus 5? 6 and 1. Sign in the middle, remember always goes in the bigger guy there. Minus 6 plus 1, that makes minus 5 in the middle. And then, it's just opposite, right? I just jumped to the final answer. Plus 6 minus 1, plus A. A lot of A's. There it is. Good on that. Now, number 9 is going to be a little more work because the log's not alone. We're going to have to do the step 1. Get the log alone stuff. So I'll flash over if you're okay with that.
Bless you.
So to number 9. All right, so number 9 here. 6 plus 4 ln x is 4. So yeah, so first get the log alone. So before you can do the cross off the log base stays the base thing, you got to get it alone. So subtract that. And what do we get? 4 ln x is minus 2. Oops, I'm getting scribbly here. Divide by the 4 on both sides. And then you get ln x is, just reduce that, right, to be minus a half. Good to there. So that was all step 1. Get the ln or whatever log you have alone. So all of that is get the log alone. And then step 2, lose the log. Base stays the base. Other to switch. So now, at this point, I will cross off the log. And once I got it alone, now it's alone. There's nothing in front of it now. Cross off the log. Base stays base. What's the base? Yeah, remember ln has an e base that it doesn't show. So cross off the log. Base stays base. So e will continue to be the low down thing. The other two switch. Instead of e to the x, it's e to the minus half. X goes over there, and we're done. X alone. E to the minus half. C it is. Good? Questions? So first had to get that log alone, right? That's the trick on that one. All right, I'm going to move on. 11 are super easy if you have the right game plan. Let me give that to you. So horizontal asymptote, it's all about the numerator power, highest power, and the denominator, highest power. So here's the horizontal plan. The recipe for horizontal asymptotes. N equals numerator highest power, and D is denominator highest power. So and then there's like a whole table, remember I gave you? If the denominator power is bigger than the numerator power, that's what we have in number 10. Then the horizontal asymptote is y equals, or just have this on this is for your 3x5 card. Number 2, if they're equal, then the horizontal asymptote is just a over b, and a and b are numbers in front of highest power terms. If the numerator is bigger than the denominator by only 1, then it's an oblique. That's the oblique case. Oblique asymptote. And you long divide the denom into the numerator, and up there you get the equation. And finally, step 4, if the numerator is bigger than the denominator by 2 or more, there's no horizontal asymptote. So there's the 4 cases. You want to just have that right in your 3x5 card, and these questions will be free points, basically, if you have that, I think. So let's take a look at it. So looking at so for number 10, the numerator power is 2. The denominator highest power is 4. So we don't care like front or back or whatever. We just care wherever the highest is. So the highest power on the top, highest power on the bottom. On that, Cyrus?
What does 3 say?
What's that?
What does 3 say again?
3 says if if n is greater than d by only 1, it's an oblique asymptote. Denominator divides into numerator. Okay, so you look at this. We have denominator bigger, huh? Denominator bigger. Horizontal. The horizontal is y equals 0. Y equals 0 is not here, so it's none of the above. Is that good on that? The answer should have been y equals 0, and they didn't put that answer there on number 10. So it's none of the above. And then number 11. Everybody see that one? So what's the, here's the highest power term in the top and the bottom. So the numerator powers 2, denominator powers 2, they're the same. They're equal. They're equal powers. So what does that mean when they're equal? It's A over B. A and B are the numbers in the front. What? The 6 and the 4. It's 6 over 4, reduce it, 3 over 2, B. We good there? So those are quick, not much to do.
No weeks on the exam.
Probably not.
Okay, great.
I'm not sure though. No guarantee. Good there? That makes sense? Remember why that is? I hate to just give math kind of blind steps. Remember, that's because a horizontal asymptote is what happens as you go off to the right forever. Right? A horizontal asymptote is like what happens, like we're saying, as you go way off to the right. You know, like 100, 1,000, 1,000,000, 1,000,000,000, way off to the right into behavior. Does the graph level out? Does it fly up, fly down? What does it do way off to the right? Where you're talking about plugging in things like x is 1,000 or 1,000,000, or really, really big numbers. Well, if you're talking about plugging in really, really big numbers, which is way off to the right, then all you care about is the most powerful term, top and bottom, because they dominate over the smaller powered terms, right? If you're plugging 1,000 into x to the 4th, 1,000 to the 4th, that's gigantic. 36 times 1,000 is nothing compared to 1,000 to the 4th. So that's why it's all about the most powerful term, top and bottom, when you're talking about horizontal, because it's way off to the right. That's why all that matters. So all of this logic is just taking the most powerful term in the top, most powerful term in the bottom. They kind of like have a tug of war, right? If the one on the bottom is more powerful, like in number 10 here, the bottom is more powerful. When you plug in 1,000, the top is only 1,000 squared. The bottom is 1,000 to the 4th. The bottom is way bigger. So if he wins the tug of war, he's going to flatten that graph out, and he's going to flatten down to 0. That's why it's y equals 0. And on you go with the rest of the logic. So find the vertical. So vertical, how do you do vertical? It's all about denominator equal to 0. So you just don't even care about the numerator at all. Just grab the denominator, say your 0, solve it. So you got to factor that. So that means x is 0 or negative 49, right? A. Good? You just, what makes this part 0 is 0. What makes this part 0? Negative 49. Plus 49 would be 0. Just whatever makes the bottom 0. Those are the vertical asymptotes. Okay, so this is the river problem. The river here. Remember we had a couple others, didn't we? What do we have, like a box? Was that the last exam? I'm getting confused. I don't know. Feel free to look back. I would look back at the homework. So we're putting, like we're making a pen with some fencing. Be careful what they give you for x. Pay attention. It says, let x be the length of the side perpendicular to the river. So that means this and this are x, aren't they? Because see how they hit the river perpendicular, make a T into the river, right? So those are x. What's the other side? Call it y, or call it whatever you want, but you can't use x because it's different, right? This side is different than those two. So you need a different letter, right? Good. Now, those are lengths. Now we got to do cost. What's the cost? Well, it's $4 per foot for the side parallel. That's this side. That's parallel to the river. $4 per foot, so the cost of this part is 4y, y feet at $4 per foot. The cost of this part is 7x because it's $7 per foot times x feet, and the cost of this part is also 7x. Again, x feet at $7 per foot. So they want the total cost function. What's the total cost function? Well, first off, you got the 4 corner posts at $20 each. 4 times 20 is 80. Good there. 4 corner posts. A post, a post, a post, and a post. 4 times 20 is 80. Plus 7x, plus 7x, plus 4y. So we have the four corner post, the top, the bottom, the right. 7x, 7x, 4y. So that is, the cost function is 80 plus 14x plus 4y. Now that's the answer, except we can't have that y. See all the answers over here have x, not y? So we got to get rid of that y. How do we get rid of that y? Remember what we do on these kind? We always use the second fact, second equation, the 2,000. We have not used that 2,000 yet. What does it say? Area is, what's area? Space in the middle of the rectangle. Area is 2,000. What's the area formula for a rectangle? Length times width. So the 2,000, the area, what's length and width? X and y. Right? X is how wide, y is how tall. So there we go. You can solve that for y now and plug in. So divide by x. Y is 2,000 over x. Plug it in right there. So you get, well, let me write it like this. So you get 80 plus 14x plus 4 times y. And what is y? 2,000 over x. Everybody see that? This is y right here. 80 plus 14x plus 4 times 2,000 over x. So if you look at the answers, it's none of the above. It's not there. That good? I better keep moving. Beyond the Just push the buttons on your calculator. Here's the key word. So again, identification is the lot of the battle. There's one word that needs to jump off the page and tell you what to do. Highest. That means max. Right? If it said lowest, that would mean minimum, right? So look for that key phrase, highest or lowest, maximum, minimum, biggest, largest. Those all mean max, don't they? The English calls that a superlative, the most extreme case. Right? So when you see that, you go, oh, it's calculator. Graph it. Find the max. So y1 equals, remember when you type this in the calculator, got to put parentheses around the numerator and parentheses around the denominator. So parentheses, and just make that t and x. Doesn't matter what letter. 12x plus 4 divided by 3x squared plus 2. Type that in, graph it, hit max. You'll find the t, or it's the x, whatever, tx, whatever. And you'll be 0.548 or something like that, which rounds to 0.55, and it's c. So that's just graph on the calculator, nothing more than that. Number 15, find the inverse. How do we find an inverse function? Yeah, we invert or switch x and y, and step 2, solve for y. So switch x and y, solve for y. This is y over here, as you know, f of x is y. So you got to switch them and solve. So this will become x equals 3 over 5y minus 2, won't it? So I switched x and y, solving for y. So I switched them already. All right, I switched this with this. And now I got to solve this equation for y. How do I solve that now? Cross multiply. Remember when you have, this is x over 1. Remember when you have two fractions equal? You go diagonal, diagonal, cross multiply. You might remember from algebra cross canceling. Cross canceling is when you have times in the middle. If you're multiplying two fractions, you cross cancel. But if two fractions are equal, you cross multiply. So x times 5y minus 2 is 1 times 3. Cross multiply. Multiply here. 5xy minus 2x. 1 times 3 is 3. Good to there so far? What are we trying to do? Solve for y. So just jump the 2x to the other side. I'm going to move it over here. You get 5xy equals 3 plus 2x. And then divide by the 5x. There it is. It's not there. It's none of the above. That good? Inverse functions. All right, I'll keep moving. Right, you know, you just go out to just youtube.com and type in Brett Herron, right? My name's on the original syllabus. Just search for Brett Herron, youtube.com. Somebody asked me last period, so I want to make sure everybody knew. Right? Let's go to youtube.com, search for Brett Heron, it'll be out there. All right, so number 16, another inverse. So this is a harder one though. So switch x and y, this is y, switch x and y, so x equals minus 8y plus 6 over minus 9y minus 6. So step 1, switch x and y, just did that. Step 2 now we need to solve. How do we solve? Put this over 1, diagonal, diagonal, cross multiply. Like that. And distribute. Minus 9xy minus 6x. Distribute minus 8y plus 6. We good to there? Okay, now it's a little difficult. We're supposed to do step 2, which is solve for y, but notice the difficulty. Y is in 2 places. It's here and it's there, 2 places. So you need to have a whole recipe, game plan, for how you solve for the letter in 2 places. Solve when the letter is in 2 places. How do you do that? Step 1, get them on the same side. Get those 2 things on the same side. Step 2, factor out and divide. So that's the game plan. When the letter you're looking to solve is in 2 places, so we have here, you got to get them on the same side, factor out, and divide. Now, and you want to have that for sure. There'll be one of these on the exam. This is really important for calculus, so absolutely there's going to be one like number 16 where you got this 2 places thing, because this happens all the time in calculus, trying to get you ready. So what do? You got the y in 2 places, so you get them on the same side. So I'm going to grab this guy, and I'm going to jump him over here, and I'll grab the 6 and jump him over there. So I'm going to end up getting both the y's on the right side, but you could get both the y's on the left side. It doesn't matter which side. Just get the 2 y's on the same side, the other stuff on the other side, just separate them out. So what do we get then? We get negative 6. Remember when they jump over, they switch signs. Minus 6x equals minus 8y plus 9xy. Is that okay to there? Can you read all that? Let me move this over a little bit. Okay, and then factor out the y, huh? Like that. We get there, so I factored out the y, and now I'm in position to get it alone. Divide by minus 8 plus 9x, divide by minus 8 plus 9x. Boom. Y is alone. That's the inverse function. Now, everybody good to there? Because I want to show you an important thing. That doesn't, the answer is going to be A, but it certainly doesn't look like A right now, does it? How do I know the answer is A? Everybody tracking with me? Make sure you hear this. This is really important. The answer is actually A. The reason I know it's A is because of the fact that every sign is the opposite, which means it's the same thing. You could just multiply top and bottom by -1. Did you know that? It's an important lesson. Multiply top and bottom by -1, you won't change anything, right? Doing the same thing top and bottom. Boom, boom, plus 6 plus 6, plus 6x plus 6, right? Boom, boom, plus 8 minus 9x, plus 8 minus 9x. Absolutely. Which means my answer is the same as A. All the signs, every sign is the opposite. So it's the same. If you have just a couple different, but a couple the same, that's different. But if every sign is exactly the opposite, that's the same answer. Just multiply top and bottom by -1 for a fraction, because you can multiply top and bottom by -1, right? Is that good? Is that making sense? I am not making it even close, huh? So let me say this. The other class, for whatever reason, I had more time, and I made it through. So look at their YouTube, the Tuesday-Thursday class. So go on the Tuesday-Thursday practice exam 2 YouTube. I made it all the way to the end on theirs, so you can see the rest of the problems.